Hey friends, welcome back to the channel. If you are new here, my name is Alex and today we're going to talk about cross-origin resource sharing and making it work with Spring Boot and especially with Spring Security. So before we dive right into the code, let's quickly talk about what CORS actually is. And in a sense, CORS is the opposite of the same origin policy that modern browsers usually enforce. So the idea is that if you're running an application at example.com and that application needs to fetch data from an API, it usually should only be able to access it from the same domain, which is example.com. So what you usually don't want is an application going to another API or another party on a different domain, such as your banking domain, for example. So this is why browsers prevent access to these APIs unless those APIs permit access using CORS. So this is all based on HTTP headers, and we'll get to that in a second. So for this tutorial, I want to show you how you can enable CORS on individual endpoints, how you can enable it globally, and most importantly, how you can make it work with Spring Security. So with that said, let's code. All right, let's check the IDE. As usual, let's check the dependencies first. I'm using Spring Boot version 2.7.3 as usual. And you can see there are two dependencies that are brought in. The first one is a Spring Boot Starter Web, which we need for the REST controllers. And I also added the Spring Boot Starter Security already. However, I just commented it out for now because I don't want to have it on a class path during the first part of this tutorial. So let's get started by adding a controller, and we call that the user controller. This is a REST controller, pretty default stuff here. Nope, not this one, this one. And I just want to have one endpoint. I have a get mapping. I use me, and I just want to return. So the idea is to return a current user. I'm not adding a service or a data layer in this tutorial. All I'm doing is just returning John Doe. So this is really all, and let's quickly start the application, making sure it all works. So it should be quite quick. There are no errors. That's good. Let's go to the terminal, and now let me just do a quick call to see that it works. So this is what we always do, right? This is a HTTP GET request to /me, returns an HTTP 200. Nothing fancy at this point. This is what it usually all looks. However, there's one thing. Right now, CORS will be disabled because it's kind of it has to be explicitly set by the server using provisional headers that we will see in a second. So right now I could tell CORS is not enabled on this endpoint. So let's change that and add the annotation that will enable it. So we can go to the get mapping directly, and I can just add the cross-origin annotation here, and now it's enabled for this specific endpoint. Now, how would I know? We just rerun the application, and let's quickly go to the terminal again, and we just perform the same request again. And now we can see the response has changed a little bit. You can see it's still 200, which is okay, but there are 3 more headers that used to not be there before. And they say the response can actually differ based on these additional headers that I as a client could provide. So the origin, the access control request method, and the access control request headers. And we start with the origin. This is usually what the browser sends to the server based on the URL that you're on. So you can see there are only these 3 additional headers, but what I can do now is use something like this. I can specify an origin. Again, this is what the browser is doing, but since there's no browser around here, I'm doing it manually. So I could just tell the server, look, the origin is http://localhost, and we can send it off. These headers are the same, but there's a new header, which is this one. It says access control allow origin and the asterisk. So this means actually the server allows any origin essentially. So this is the default setting that you would use for a fully public API, but we get to see how we can restrict that in a second. But right now you can see, okay, the server allows any origin to access that endpoint, which is nice, right? Now we could do this, and now it would also work in the browser. So this is all there is to enabling CORS already. And while we are at this, let's also check a different concept, because usually what browsers will do before they perform the actual request is something that's called a pre-flight request. which the browser is performing to figure out if it's allowed at all to access a certain endpoint. So let's see what that looks like. That's usually, so this here is a GET request, right? But what browsers are doing is using the options method. So it's asking for the options on that endpoint. And now you will see the server replies with, okay, you can perform a GET, which we've just done, head and options on that resource. And this is the pre-flight request, and we can see that has succeeded. And we'll see what it looks like if it doesn't succeed in a second, because what we're doing now is, I could use the cross-origin annotation on the specific endpoint, which is nice, but I could also move it up here, which makes it a little bit easier if I have multiple endpoints, right? And the final stage is having the global config that we get to in a second. But what I want to show you is that we could now provide specific origins, and that's an array. So I could tell, okay, look, if you're coming from HTTP localhost, you're allowed to access that resource. So now with that origin in place, let's quickly rerun the application, restarting it, and then we go into the terminal. And now if I just perform the same GET request, right? So I'm performing the HTTP GET request towards /me, and I'm providing, let's go with, yeah, example.com is just fine. So this is a different origin than the one that is allowed here. And now if I just run this, it says invalid course request, and I'm getting an HTTP 403, which means it's forbidden for me to access that. So before we used, or we've seen the asterisk, which means any origin is allowed to connect. But now this is no longer the case. So if I'm going back to localhost here and I perform the request, I can see again it's working. But now we also see that the access control allow origin response header has changed from the asterisk to the origin that I'm using. So that would tell a browser, okay, you're accessing from http://localhost, which is fine. I permit that. Just go ahead. And this is all there is to it. All right, so now let's see how we can actually use a global configuration. I'm removing that, although I could use it still as a supplement to the global configuration, but I'm getting rid of it here for now. And now we go to our Spring Boot application. So that is also a configuration, which means I can add beans to the Spring context. So let's call that course. The name is not the best, I have to admit, because we need to return a web MVC configurer. The way we're doing this in Kotlin is using the object keyword to create a singleton of that, like this one. And now we override one of the methods, which is add course mapping. And this will provide us with a course registry, and we can use that to now specify individual course mappings or global course mapping as we're going to do. So we can do registry, and then I can say add a mapping. That's how it starts. So this means any mapping that exists right now and will exist in the future. So that really is the wildcard mapping that we're adding here. And now I have to provide the origins. Now let's actually provide multiple. So I'm saying, okay, localhost is fine. And I could also say, look, http example.org is fine. So I can have multiple explicit origin. And this is also something that you have to configure in production applications. The reason being that even a port makes a difference. So if I have localhost :3000, that is a different origin than 4000. So that has to be really explicitly specified here, and that can be a pitfall for enabling cores for your single page applications if you have them. So now I have to specify the methods that are allowed. And I'm just again saying all the methods are allowed. So this would be something that is close to a public API that can be used from anywhere using these origins. And this is all there is to it. So let's quickly rerun the application again and see if that still works. So there should be nothing that has changed at this point. So let me just try that. So you can see that works. I can still access the /me resource, and now I can also do it using example.org. That also works. It says, okay, that origin is allowed. Now if I change something here to .com, which is not allowed, then I'm getting invalid course request, which means that origin is not allowed to proceed. Okay, so now finally, let's add Spring Security to the mix. I'm just changing that here. I have to resync. And now Spring Boot has dragged in the starter security, so that means it's on a class path, and by default Spring Boot will just lock down the application. So, but what does it actually mean? Right now, if I just restart the application, all of the requests are authenticated. So that means we can see there's a password for the default user. If I just now try to access the application, it's blocked, right? You can see I'm not allowed to proceed. I'm getting HTTP 401, and this unfortunately is even true for the option requests. Yeah, that's an error message that is expected because it's not called option but options. So you can see it says, okay, I have to authenticate using basic authentication, which has been enabled by default. But I'm no longer able to perform the pre-flight request as well, because that's now also getting the unauthorized error. And this makes it hard for especially single page applications, because usually you have endpoints that accept some sort of username password and return a JWT, something like that. So that should support pre-flight requests. But the thing is that Spring Security kicks in first and doesn't even forward these requests to Spring Web MVC. So now what we have to do is we have to make Spring Security aware of our current course configuration. And we could do this like all by hand, but the best way to actually doing this is by adding a new bean. And this is the security filter chain I just called chain that accepts the HTTP security. Should be this one. I always say it's a security filter chain. Security filter chain. There we go. And we have to return HTTP build eventually, but the way that we can make Spring Security aware of the existing configuration that we have here, like this global one, is by just invoking HTTP course. And that's really all that we need to do. So right now, Spring Security will pick up the existing config and now, okay, if there are pre-flight requests, I have to forward them to Spring Web MVC, which can reply, and then I can still block the other requests. So let's rerun the application with this one. And let's go over to the terminal. Now let's run the pre-flight request on /me for this origin. We can see it's invalid course request, which is good, which means we have passed Spring Security already, but it still says it's invalid. And why is it invalid? Well, because I've been using example.com, whereas only example.org has been approved as an origin. So I'm changing that back to example.org, and we can see that has succeeded. So it's an HTTP 200. It tells us still that these are the allowed methods that we can use. It says that http://example.org is allowed as an origin, and we can actually proceed without being blocked by Spring Security. There are more ways that we can make this work, but this is for me the most straightforward that we can use, especially with Spring Security. So that wraps it up for this video. Let me know in the comments down below if you have any questions. Consider subscribing, and I'll see you in the next one.